Hello there and welcome to the new tutorial where we will going to discuss the cross-validation, which is a simple but a very powerful approach to create better statistical model in data science. So I got a lot of requests where people asked me to explain about the cross-validation, and I have created a small presentation, then a code within the Python which you can follow to run the cross-validation. Alright, so let's first understand what is cross-validation. So what is cross-validation? Well, in theory, or in my own words, it is an advanced approach to split the data sets into train and testing. So we have a conventional way or the normal way by which we just split the data between training and testing data set using the train test split method. So if you have used the machine learning or within the Python, there is this train test split method where we can specify the x and y variable and then specify the test size, and generally you take the test size as 30%. So what you are doing is only specifying or only dividing the data set between two sections. One is training, another is testing. Now in cross-validation also you do the same but with a twist, which I will show you. So as I was saying, it is an advanced approach to split the data set into training and testing to make sure each observation become part of training. So that's the key part, to make sure each observation become the part of training and testing data set to ensure the complete representation of data for better model. So that means when you will build the statistical model or when you will train the model, each and every observation using the cross-validation will be validated in this model. So your model will be much more robust and exposed to the entire 100% of the data for giving you the best result. Now, here is an existing approach. We have 70% of the data in training and 30% of the data in testing. That's using the train test split method, or in R or in any other tool you are using the way you want, but that's how we usually do it. Now from this, if we transition it to, let's say, 5-fold cross validation. Now 5 is just an arbitrary or a random number which I have picked. Now it can be 10, it can be 8, it can be 3, or it can be 15, but you just need to keep in mind, if you increase the number, the processing of the data will going to increase, because in 5-fold cross validation the data set will be divided into 5 small data set, and it will have 5 iteration. How? Let's see this. So here if you see, the data is divided into 5, 1, 2, 3, 4, 5, where 4 data sets are considered as training and 5th is considered as test. That means out of 4 data set, 1 will be testing data set. Now in the second iteration, you will have first 3 as train, 5th as train, but the 4th set is test. Now in the next iteration, you have first 2 as training, then you have 1 test data set, then rest of the 2 training, and similarly over here the test is basically the second data set and the rest of the data sets are training. And in the 5th iteration or in the last iteration, you have first data set as testing data set and rest of the other data sets are training data set. So this way you can see that first we divided into the 5 main data set into the 5 data set. 1 is the testing, and as we are moving on the iteration, the testing set is changing hands. This way your model is using both the training and testing data on the 100% of the data set and have the best knowledge out from your data. So that's in a nutshell what you have the cross validation, or what usually happens in the behind of the scenes when you run the cross validation. Now cross validation you run it with the help of the grid search method, because when you apply this entire procedure on a model, you need to apply it on a statistical model or on a data on which you want to create a statistical model. And grid search basically have this option where you can specify how many x-fold cross validation you want, whether you want 5, whether you want 10, because it has a CV parameter as 10. So let's see how you can implement it in the Python. Alright, so here I am in Python, and what I have done so far is only importing the data by using the pandas library. So I am importing the pandas library as PT. Then I am creating a data object or the pandas data frame object by importing this file. You can find this file in the description section, where using that link you can get access. And then over here we are using the info method, and we see that it's 534 MB. Now if I use the entire size, this will going to take hours within the grid search, because it's a very resource intensive. So what I will going to do to demonstrate here is subset the data set. So if I show you the fraud, because fraud is something what we need to predict from this based on the different column. So first of all, let's quickly check the data set, which is data.head, and here we have these columns where the payment type is present, and rest of the columns, if you see, mostly are numeric except this and the payment type. So what I'll do is I will quickly remove these columns because we don't need it. So if I say data equals to data dot drop, to drop the column, and what column we want, name and name destination, because those are just the unique rows, and name test, and the last one is flagged fraud because that is also not. So whatever column you want to remove, you can just go ahead and remove it from here, and we need to provide the access equals to 1 because we want to remove the columns. All right, throws an error, is flagged fraud not found in access. Okay, let's see this, which column it's at. Name origin is flagged fraud. Okay, name ORIG, name test is FLAGGET, and FRAUD is FL. Okay, there is the spelling mistake. Now if you see, the data set, now we should not have these values, right? Okay, so for model building, what I need to do is convert this into the dummies variable, because these are important variable type, the payment type. Then to convert that, what I need is basically a dummies method. So I'll just create a dummy variable over here, or dummy object, and use pd.get_dummies function, and provide data.type over here. Now it should have dummy.head. For each of the payment type, it has created variable. So wherever the variable is used or the payment type is used, the 1 is present. So for row 0, 1 is present. For 1, 1 is present. Similarly over here, wherever the payment type, particular payment type is occurring, you have the payment type coded as 1. Alright, so now we just need to concatenate that. So data equals to pd.concat function to concatenate. So we need to concat the data and dummy, and we need to concatenate the columns. Alright, so let's execute this. Now if I just check, we should have the rows over here. Now let's go ahead and create the x and y variable. So my x variable, I just don't need this variable and this variable because fraud is something we need to predict. So x equals to data dot drop, and I want to drop type, and is fraud, and dot values. and I need to provide the access equals to 1 because we need to drop the columns. So what it is doing is it is returning the entire data set after dropping the type and is fraud column, and dot values is making sure that it's in the array because the machine learning accepts the array as a value. So if I execute, this is what it will going to produce. Why? So one thing which I would probably do is, because it will going to take a lot of, if I show you the shape of the data set, it has 6.3 million rows, and what I need is I want to reduce this data set. So what I can do is data underscore fraud equals to, just take entire data from this data dot is fraud equals to 1. All right. So what we are doing is we are taking all the fraud values which are somewhere around 8,000. So if I just execute this, and if you see data underscore fraud dot shape, then you have 8,213. Similarly, if I just copy that and paste it to get just the 20,000 rows, so overall my data set will be of 28,000, which is faster to run. So data underscore no fraud then equals to 0 dot head. What it is making sure is I will get the first 20,000 for data where no fraud has happened. So if I now see data underscore no fraud that shape, you will get 20,000 rows and 13. Now I just need to concatenate this. So I will just create one more row, and that is the data equals to pd dot concat in that data underscore fraud, data underscore no fraud, and this time access equals to 0 because we need to concatenate the by row. So if I execute that, you will get the data dot head as like this, right? So you can even check shape, which will return the 28,000 rows, as you can see it over here. Now if we drop these two columns, it will give me X because type is something we have converted into a categorical variables, is fraud is something a target variable. So let's go ahead and do that, and Y equals to data dot type dot data dot is fraud because this is a target variable. So now I have the X and Y values. Now I can go ahead and implement the grid search. So first of all, we need to, since it is a classification, I will use the logistic regression. So from sklearn dot linear model import logistic regression, and from sklearn dot model selection learn dot model underscore selection import grid search CV. As you can see, CV is present, which is cross validation. Now if I say log underscore reg equals to logistic regression, I'm just initializing with default parameters, and after that what I need is grid search CV. So grid equals to grid search CV, and what you will specify is the model, and CV equals to 10. It has the capability where you can get lot more than just this. For example, we have the penalty L1 and L2, we have the C value and a couple of other values which you can provide it into the grid search CV, but this is not what I am doing. If you want to see, you can see my previous logistic regression and KNN regression where I've completed it into a detail, but right now I'm just going ahead and putting it. So it's saying one positional argument required, which is param grid. So I will provide one argument which is nothing but the value of, let's say, penalty. Okay, so penalty, and that is, let's say, L2, but the default one I'm providing. As you can see it over here, penalty is L2, so that's the default I'm providing, comma, because it is expecting one parameter. All right, there is some need to be sequenced or np.nd array. Okay, let me put it like this, and now it's executed because I provided it like a list. It was not accepting it as a normal array. Now what I need is grid.fit based on the x and y values. And if I grid capital G grid.fit, it will give some warning, so just ignore that. Now it has run using the cross validation as value 10. This is the cross validation value we provide. Now what it gives us, some parameters like grid.best parameters. So penalty L2, something which we provided, is what it has given because that's the only default value, and it also gives us the score. So grid.best_score is what 83% is something what it is giving us. So you have the option that first you can just apply this logistic regression on these values. For example, if you say log_reg.fit and x comma y, so it will fit the value, the parameter, and then log_reg.score based on the x comma y value, it will give you some score. So in this case, if you see, the logistic regression model is giving you the better score. However, I will going to trust more on this data set because it has a splitted, or this 83%, which is a penalized score because it has splitted the data set into 10 different validation and then gave us the score of 83%. So this is saying that this is the best score once you split the data and run the model on the entire data using that train and test split. But you, as I showed you, you can also directly first check what is the default one. Also, you can use the train test split method, which I have explained in my previous videos, which also is one of the previous old way of doing the splitting the data set. But that's about how you can specify the parameters within the grid search CV for the cross validation equals to 10 and the model and the respective at least one parameter, that's what it expects, and then get the score and the best param. So I will just also mention the best param, so that best params, and it will show L2. You can come to basically both L1 and L2, for example, comma L1, and if I execute this, it will run it again based on those two parameters. All right, now let's see the score. Now see the score, you have 98% from 83% to 98%. It's a huge jump, and mainly because we used two different parameters, L2 and L1. So I'm sure now the best parameter will be L1. So as you can see, so it has lot of scope. As you can see over here, you can provide parameters L1 regularization or L2 regularization, and over here I already showed you it has a lot of different parameters as well. Like one of the parameter is this, which we want to tune it. So see it in my previous video for logistic regression if you want to know more about it. But yeah, that's mainly about how you can implement the cross validation with the help of the grid search algorithm. So that's about it, and I'll meet you in the new video, the new topic.